Here's the outline that I put together and suggested for everybody involved. You see, I'm not going to be talking most of the time. Al's going to be talking this morning. This afternoon, I'll give you a little bit of background on a really important development that we got to report. And then I'm going to turn it over to Chip Atkins and Paul March and Michelle Broyles. The team, I think, needs to be mentioned because there were a bunch of people. You know that we had both NIAC 1 and 2 grants over the past 3 years. And the phase 2 people, all of these people, and I'm scrolling through them. Let me single out Gary Hudson for special notice. He's the president of the Space Studies Institute, a friend from the mid-2000s, 2005 or 6 or something like that, at a state meeting. We met and so forth. And the SSI, primarily at Gary's instigation, has been a supporter of this project all the way along. We wouldn't be here talking about this stuff if it were not for SSI. Okay. The next one of special note, who you may not know, is Dan Kenefick. Dan is a world-class GR type who I met at a meeting in Notre Dame back in 1996. So on, we remain friends. He's world-class. He knows GR as well as anybody probably alive on the planet, with perhaps the exception of Kip Thorne. Okay. And he has not said, hey guys, that's just nonsense. Okay, which is really encouraging. And I'm really delighted that Dan's involved in the project. Okay, you know Paul March. Jonathan Woodland's the university machinist and a capable mechanical engineer in his own right. And he's been building, machining all of the stuff that I put together and then give to Hal in the IHOP parking lot. And she takes them into the lab and runs them. Though the last few weeks I've been able to get back into the lab, the coronavirus thing and so on. Okay, now, in my remaining 10 minutes, see, I told you I wasn't going to get too far astray. Okay, background, Huntsville. I'm just going to say a couple of words about that. A year ago at this time, we were dealing with calibration and vibration issues, okay? And as a matter of fact, when I did the presentation at the NIAC symposium in Huntsville, I spent most of my time talking about those two issues and not so much about the issue that David Brin brought up at the end of my talk. He said, what about more thrust? Okay. He wanted to hear about more thrust. He was not interested in the calibration issues that involved George, by the way, and the vibration issues that involve Michele Shiru's on the list on the circulation that I send out of occasional updates. Michele had recommended a Polytech vibrometer, and we had gotten one of them, and the vibration issue was pretty much put to rest with the vibrometer. Okay, more thrust. More thrust is a story of L brackets and rubber pads and nylon washers. Okay. And I'm going to get out of Microsoft Word here at this point. Aha. And I'm going to go to pictures. And I've got L brackets and rubber pads right here, 2 pictures. L brackets, and to understand how this project came to develop the way it did, you have to understand a little bit about the history of it. The L brackets and rubber pads go all the way back to 1999. Okay. Here's the first picture. Let's see if I can get this up full screen. We're pretty near. Okay, these are, by the way, snagged from Starships and Stargates, the science of interstellar transport and absurdly benign wormholes, which is a nod to Kip Thorne. Okay, PZT stacks, brass discs, aluminum caps. You all are probably familiar with the general structure of these things. That's a longitudinal sectional diagram on the left. On the right is the picture of one of the original devices of this sort built in 1999. There are, I think, 3 of them still in existence. Paul March has one, Martin Tamar has one, and I think Gary Hudson has one of them. Okay, as you can see, they're a little bit different from the ones that we're running now. The brass disc is only 3/8 of an inch thick, which is thin by comparison with the ones we're using now. The stack's roughly the same dimensions and the cap's roughly the same dimensions. And you'll notice that this is mounted on this piece of thing, the mounting bracket down here. The reason why that's there is because these things were suspended from a torsion pendulum in the following arrangement. This is the L bracket here, okay, and it's bolted onto the back of the brass disc. And you'll see very prominently displayed in this picture the noted rubber pad. It turns out these devices don't work without a rubber pad. They're just essentially nothing. When I put the rubber pad in initially, I did it to decouple a high frequency vibration from the torsion pendulum. And indeed, it did that, decouple the high frequency vibration. And it also made them produce very obvious thrust. This was done, as I say, on a long suspension of 1.5 meters, I think it was, suspension torsion pendulum with a little mirror on the axis of the pendulum. And the mirror with a laser pointed at it would produce a displacement of the laser 2 meters away on a cabinet of several centimeters when this thing was turned on. Okay, that's the reason why these things have developed with L brackets and rubber pads. And I see that I'm ahead of time. Actually, I'm on the time that I scheduled for myself.
Thank you. You just keep on going.
Okay. Okay. The reason why the devices that we've been running for the last decade, basically, because in 2010, I decided to stop paying attention to other people and build the best thing that I had built over the years, and that was these gizmos, okay? And they had L brackets and rubber pads. Indeed, they had L brackets and rubber pads up until about 1.5 years ago, where we started fooling around with nylon washers. And that's my cue to Hal to take over, because I'm not going to talk about this anymore. What she's going to tell you about is how in February the campus got closed down because of COVID, and where we had been sort of working together and all of that, all of a sudden a new arrangement was set up. She did the stuff in the lab and I did the stuff, built stuff at home. And actually for most of the spring, we didn't get much machining done because the university was closed down. We worked with what we had, and she's going to talk about that. And then this afternoon, I'm going to come back and tell you about how this got fundamentally changed, and a couple of duh moments that led to some really substantially improved behavior. We'll talk about that. We've got movies to show you. And as I said, I'm not going to be doing the talking. Michelle and Chip and Paul are going to be doing the talking. So Hal, it's all yours.